this is what they found. What they found is, if you just plot the look-back time, so this is further and further back in time, further and further away in space, and this is essentially the plot of what you see for alpha.
Yeah, unfortunately we haven't got images of what he's referring to, as other pointed out earlier, but this is not really relevant. This is still building upon things of Einstein.
And you see that alpha becomes smaller. This is blown up, it's a tiny thing. We're not talking about the big variations we need for explaining the horizon problem. We're talking about the residue some 10 billion years ago. And this is basically what they seem to have observed. They seem to have this very, very kind of nuance here, this feature, which is very significant. It's controversial, and this continues to be in dispute, but I think it's interesting. There might be some observational evidence for a varying alpha. Now, everyone always asks at this point, so what does this mean? Is it a varying C? Is it a varying E? What is it? And I don't know if there's any physics students here, so I'm going to leave this as a problem for the student. And I'm going to give you a hint, though. So this is, you can actually address the question. If you have a varying alpha, is it a varying C or whatever it is? So think a bit about this. Where do the constants of nature come from? So typically, they're very closely related with our understanding of what are the units of measurement. The constants of nature are things that don't change. The units of measurement shouldn't change. I don't want to measure things with a meter stick that keeps changing back and forth. Okay. So the units of nature and the constants of nature are very closely related. And for example, it is again for the physics student in the audience, Newton's law is the statement that the force of gravity decreases with this combination, and therefore you get this proportionality constant, that's Newton's constant. Well, Galileo, before Newton, thought actually the acceleration of gravity was a constant. So this is what you use whenever you launch a rocket into space. Gravity becomes weaker and weaker in height. Galileo thought it was the same. It kept going up and the acceleration of gravity was the same. Now this confuses a lot the physics students, which is why I like to do this. Consider now that I decide to do the measurements with a pendulum clock. So the pendulum clock is something, I go to the moon, and instead of taking, an electronic clock, I take a pendulum clock. It's a bit stupid, I know, but you just take a grandfather's clock to the moon, and that's what you use to measure time on the moon. It's a bit surreal, a bit ridiculous, but if you think a bit about this, if this is your unit of time, this is the valid law. i.e. Newton's law is actually wrong, and Galileo's law is right. If I insist on going around the universe...
Talking rubbish there about Newton being wrong, what you've got here with a pendulum clock, it does depend on the strength of gravity. And the strength of gravity on the Earth is different to the strength of gravity on the Moon. And so you're taking a pendulum clock on the... comparing a pendulum clock on the Earth to a pendulum clock on the Moon, and they're operating differently because the gravity is different. And that's Newtonian physics. You would, from Newtonian physics, from the way Newton deals with time, you would adjust the clock on the moon, pendulum clock on the Moon to compensate for the change in the strength of gravity, so that it would still keep time with the one on the Earth. So he's sort of like presenting a physics problem, and are you supposed to be looking at that within the context of Newtonian physics? And in the context of Newtonian physics, you are recognising the strength of the gravity field is different on the Earth and the Moon, and so you are allowing for that in your calculations when you're then going to talk about time.
Clock instead of a normal electronic clock. Electronic clocks actually tick with alpha. Alpha is the thing which determines how your watch ticks. And basically, if you have a varying alpha, effectively what you're doing is taking a pendulum clock around the universe. It's equally stupid, really. So, basically by addressing these issues of how should we define units, this is not metaphysics, but by addressing this issue, you will actually answer whether you should have a varying D or a varying C if you have a varying alpha. I really hope there's not too many physics students here, because you're going to be really confused. This is a perfect way to destroy. I mean, there's a lot of tautologies in physics textbooks. I don't know if you've noticed it.
A lot of tautology in physics textbooks. What you're talking about is you've got circular arguments, you've got a definition, and based on the definition you've got consequences, and those consequences are sort of like circling back. So it is a sense of tautology, yes. A lot of things are the way they are because. Okay.
Define one thing, the other thing is defined by the other, is like a loop. And, this is one example of where you could put the finger on it. So before I finish, I'm going to wrap this up exactly. This is the three things I wanted to tell you. And basically, let me go back to the philosophy, the philosophical issue. Physics.
The philosophical issue messed up by Einstein, because you've got the philosophy of how you're going to understand things from Newtonian physics, and now Einstein wants to change that, and you've got the philosophy of how you're going to understand things from the way Einstein's doing things.
Changing time. Well, this is a very deep question, and this is something I can be here 3 hours talking about it. It can be 48 hours if you want. But let me just give you basically the short answer is it's extremely difficult to preclude the existence of a super law telling you how the laws you observe changing actually.
So there you go, the super law again. This super law idea. You got the law. You got the mess made by Einstein by making the speed of light constancy a law of physics, and his followers are understanding it that sort of way. And then if it changes, you've then got a super law where that law is changing.
So if the laws of physics are to change, there cannot be such a super law which doesn't change above them. And the only way I know of to do this is exactly having a varying c, because the speed of light is so increasing.
So you got a varying light speed. We'll just throw away the law, the forced law that you have that the speed of light is constant. That's a false law. It's not true. The speed of light is not constant, so throw that away. So your law then becomes the speed of light is variable, and you've got that law, and so you then don't need to have the law of speed of light constant, and then the super law on top of that of saying the law changes.
Brain so embedded into the way of formulating the laws of physics. If you have a varying c, and if you do it brutally, then essentially you have variability in the physics, in the physical laws immediately. And this can be done in a way that's viable experimentally if done carefully. Perspective, you're basically saying the universe might come out of the nothing without laws and then invents the laws, and things just crystallize into a stable, c is not very much, laws are not changing much, the stable scenario. But basically the reason why that happens may be a circumstantial reason rather than a fundamental reason. And I think I should leave it here. Let me just conclude. As I said, if I start going on this, it's going to be 3 hours. So maybe let me just conclude by stating that the varying c theories are quite a strange thing, given that in 1905 Einstein proposed the theory of relativity. It's curious that actually the first varying constant theory I know of was proposed by Kelvin experimentally in 1874, and was a varying speed of light.
Varying speed of light theory from Kelvin, 1874, and this is before Einstein. So once again, you've got Einstein as the foundation of modern physics from 1905. If you just throw it away, what Einstein did in 1905, and then you're back to Newtonian physics.
So this kind of openness of mind was something which was possible before 1905. Then Einstein came up with his theory, and look at this amazing statement. In 1930, Eddington said, the variation in C is self-contradictory. This is an incredibly stupid thing to say.
Yeah, so what Eddington said was an incredibly stupid thing to say. Stupid of him to say that the variation of speed of light is a self-contradiction. And they get that mess from defining it that way. You shouldn't define it like that. You shouldn't make it a blooming law. Just messing up.
This is not something which is actually doing relativity any favor. You're saying that the constancy of C is actually a definition.
Yeah.
It's nothing physical.
When you say it's a definition, you are messing up physics completely.
Of course, it's not true. In fact, what has happened is that the physical reasons, the experimental reasons that led to relativity theory, by 1930 had been forgotten. And people had become completely embroiled in the mathematics of relativity without realizing that actually things could have been different.
Could have been different. You didn't have to go the way Einstein went. He is sort of omitting it here. Einstein did all his building, and you didn't have to do it that way. You didn't have to do the maths the way Einstein was dealing with it. You could have just stayed with Newton, stayed with Newtonian physics. It's sort of omission there. The way Einstein has gone has set everybody off on a big diversion. I'll just pick it up again.
Then Einstein came up with his theory, and look at this amazing statement. In 1930, Eddington said a variation in C is self-contradictory.
Yeah.
This is an incredibly stupid thing to say if you think a bit about this.
Yeah, Eddington's stupid.
Not something which is actually doing relativity any favor. You're saying that the constancy of C is actually a definition. It's nothing physical. Of course, it's not true. In fact, what has happened is that the physical reasons, the experimental reasons that led to relativity theory, by 1930 had been forgotten. And people had become completely embroiled in the mathematics of relativity without realizing that actually things could have been different.
Yeah, could have been different. So you got all these experiments. Einstein decides to, if he is to go by those experiments, he's not really that clear on what he's doing. But if he's going by those experiments, then he's interpreting those experiments his way. And you didn't have to do it his way. You could have just carried on with Newtonian physics. So the reasons for why Einstein did what he did are completely unclear. You could have just carried on with Newtonian physics. You didn't need to go on this massive diversion which Einstein set up. And so what does he say? He says they got people who were believing Einstein and got embroiled in the mass of relativity without realising it could have been done differently.
Eddington said a variation in C is self-contradictory. This is an incredibly stupid thing to say if you think a bit about this. This is not something which is actually doing relativity any favor. You're saying that the constancy of C is actually a definition. It's nothing physical. Of course, it's not true. In fact, what has happened is that the physical reasons, the experimental reasons that led to relativity theory, by 1930 had been forgotten. And people had become completely embroiled in the mathematics of relativity without realizing that actually things could have been different. And the quote I like very much from Einstein, which comes from around the same time, is that since mathematicians invaded relativity, I don't understand it myself anymore.
So there you go. So these people who believed in Einstein, they took all the mathematics, they turned it around into a way, whatever way they liked, and then Einstein didn't understand what they were doing with it anymore. So Einstein got completely confused. What are they doing with the mathematics? You didn't have to do it that way. If we go back to the triangle, this is the relevant one. When they form this sort of triangle, they get their time dilation from this triangle. They form maths from that, and they just carry on building on that. But why do they do that? You could just carry on with, if you do the maths properly, you could get that triangle, and that's still Newtonian physics. What was the need for all this change to doing it the way Newton was doing it? There was no need for it. There was nothing from experiment telling you needed to change. And then these people who pick up from Einstein, they just make all the maths very confusing. And Einstein's so confused by it, he doesn't know what they're doing.
In fact, what has happened is that the physical reasons, the experimental reasons that led to relativity theory, by 1930 had been forgotten. And people had become completely embroiled in the mathematics of relativity without realizing that actually things could have been different.
Yeah, they didn't have to do all that. There was no need for it. There's no need for going the way they did with the maths. And Einstein didn't understand what they were doing then with the maths.
And the quote I like very much from Einstein, which comes from around the same time, is that since mathematicians invented relativity, I don't understand it myself anymore. I think this is the situation we're in at the moment. I think...
Yeah, the situation we're in, completely messed up by the maths. Einstein makes a mess, then they create them, then they just carry on with that. They make a terrible mess in the maths, and they just carry on and on and on, and they build up on it.
A lot of the physics which is behind relativity has been forgotten, and now it's everything just so...
Forgotten. It wasn't even relevant. There was no reason for actually doing the things that Einstein did. You could have just stayed with Newtonian physics.
Much formalism, so much mathematics, that people forget that things could have been different, and maybe there's good physical reasons for them to still be different. Relativity was really due to experiment, not to mathematics.
No, he's saying, people have looked at what Einstein's doing and it doesn't make any sense. And you've got his philosophy, you've got his way of muddling up the maths and so forth, and it's not clear what's he going from. So when he's doing the maths, what experiments is he citing for doing the maths that way? What's he citing for his assumptions? He's assuming things like the relativity principle, he's assuming constancy of light, and what experiments is he supposed to be going from for that? And when you get to what he say, it all becomes very vague and he starts changing his mind. So what experiments have you got for his relativity? It's all very vague what he's going from when he's building up his maths. And then you've got other people taking over his maths, and then they're doing the maths differently, and Einstein doesn't understand what they're doing with the maths anymore. It's all just one big mess.
Not to self-consistency, as Eddington claimed. And if something is due to experiment, I like this quote as well, and I'll finish with it. Quote from Hertz: what is due to experiment may always be rectified by experiment.
No, they've messed up the experiment. They've done these experiments and they've messed them up. And they messed up the theory, they messed up the experiment. It's all a mess. How they understand what the experiments mean, they messed it up completely. It's all one ginormous mess now. They've done their maths. I'll point out the maths again. Let again. They've messed up their maths from the very beginning. They've messed up the maths. Why have they done their maths like that? Why? They've just messed it up. And then they're going to do their experiment and they mess up their maths. And they're going to understand that experiment, or try to understand that experiment, from their messed up maths. It's just one complete mess.
Thank you.
I think he says that's really supposed to pretty much be the end of the talk he's giving. Now he's going to answer questions, and I don't really think you need to go into those questions. I've pointed out what the problem is. They've messed up the maths, they've messed up understanding experiments, and they haven't really got the reasons now for doing things the way Einstein has done things. And this person is still trying to go from what Einstein did. He's trying to make a little modification from the foundation of what Einstein did. He's trying to come up with what his theory is, double special relativity, and you sort of that is just a botch. It's just another botch. And really, you should be looking at Einstein's foundations and what he's building upon from his special relativity, and say, oh, we can just throw that away and we can go back to Newtonian physics. There was no reason for going to the way Einstein was dealing with things. We can just stay with Newtonian physics. And so that's it. Conclusion. Thank you.